Hello everybody. Today we will be looking at third part of our coming series, that is alkane. In our today's video we will discuss about the reactions of alkane. One of the reaction we have discussed about it, that was combustion. Today we will discuss about the free radical substitution, and later on we will discuss chemical reactivity of alkanes. Why alkanes are less reactive? This will be our second concern of this video. Let us start the video. Free radical substitution of alkane. Alkane can give only two types of reaction, that was combustion. First one was combustion, we have discussed in our previous video. Then the second one is free radical substitution. Free radical substitution takes place under a specific condition, as a result of which one hydrogen is substituted by a halogen like chlorine or bromine atom. To substitute one hydrogen, we have to use ultraviolet light or sunlight. As alkanes are unreactive, so we have to give ultraviolet radiations or sunlight substitution to take place. What is free radical substitution mechanism? Free radical substitution reaction consists of three steps. Let us see an example. This is the solution of bromine. Bromine solution Br2, and this is hexane C6H14. When this solution is mixed but not placed in UV ultraviolet radiation, then no reaction will take place. Bromine will colorize this solution like its own color. But in the presence of ultraviolet radiation, bromine will break down and substitute hydrogen step by step in the solution. Let us see its three steps. What are these three steps? Step number one is initiation. Initiation step, the bond between halogens is broken homolytically, as a result of which two radicals are formed. In case of bromine, bromine will break in such a will form that two bromine radical. Similarly, chlorine will produce two chlorine radical. But condition is ultraviolet radiation. Otherwise, no reaction will occur between hexane and bromine or chlorine. Next step is propagation. Propagation refers to the progression or growing of the substitution reaction in a chain type reaction. It means free radicals are very reactive and will attack the unreactive alkane, as a result of which carbon hydrogen bond breaks homolytically and alkyl free radical is produced, as chloride or chlorine or bromine radical, as that of chlorine radical or bromine radical. Alkyl radical is also produced. When a bromine or chlorine molecule attack, it will produce a further radical. Let's suppose this is an alkane which is unreactive. It is attacked by this bromine radical This bromine radical will remove a hydrogen from this alkyl radical and produce HBr. This radical will further react with the bromine molecule and give a new bromine radical. This is propagation, in which new radical is being generated. Or in case of chlorine, chloride, chlorine radical will react with alkane and produce a alkyl radical. And when this alkyl radical will react to chlorine, this will produce a chlorine radical. Okay. This reaction is not very suitable for preparing specific halogen. Okay. As it is producing a mixture of substitution products. If there is enough chlorine or bromine present in all the hydrogens in the alkane, will eventually get substituted. It depends upon the amount of substituent, that is chlorine or bromine. If their amount is present in abundant quantity, it will eventually replace all the hydrogen in the compound. Like this. This is chloroethane. When second chloride radical, chlorine radical attack on the chloroethane, it convert it into chloroethyl radical. This chloroethyl radical is now reactive and can react another chlorine molecule to convert it into dichloroethane and chlorine radical. Similarly, the second chlorine will come like at this position, and hydrogen will, second chlorine will move as chlorine radical, like this. This is the chain of the reaction. When a molecule and radical combine, a new radical is formed. When a radical combine, it will stop the reaction and termination step is started. The chain reaction terminates due to two free radicals reacting together and forming a single unreactive molecule, as a result of which a stable unreactive molecule is formed. Like that, ethyl radical and chlorine radical will form a bond like pair, then it will convert into chloroethane. Similarly, same type of radicals, ethane radical, ethyl radical, or one ethyl radical will react with to form butane, or chlorine radical will react with chlorine to form chlorine molecule. Similarly, it can occur in bromine. This was the free radical substitution mechanism. Now, here is a question: why alkane give just two type of reactions, while other will give more type of reaction? We will discuss in future. There is a reason. What is that reason? Alkanes are less reactive. Alkanes are actually less reactive due to two reasons. Strength of carbon-hydrogen bond. Carbon-hydrogen bond is strong as it contains single bonds, and single bonds which are sigma bonds. Consists of carbon-hydrogen atoms which are bonded together by single bonds. Unless a lot of heat is supplied, it is difficult to break these strong carbon-carbon and carbon-hydrogen bonds. This decreases the alkane reactivity in chemical reaction. Strength of carbon-carbon and carbon-hydrogen covalent bond is much more. That's why alkanes are less reactive than alkenes and other hydrocarbons. Lack of polarity. As both carbon and hydrogen have almost comparable or same electronegativity, that is 2.5 and 2.1. So their difference is 0.4 only. As a result of this, alkanes are non-polar molecule and have no partial positive or partial negative charge. Alkanes therefore do not react with polar reagents. They have no electron deficient areas to attract nucleophiles and also lack electron rich areas to attract electrophiles. That is why we are calling them least reactive or non-reactive or unreactive. And here we have shown that the distribution of electron between carbon and hydrogen bonded atom is equally shared. That is why no polarity is being observed by any atom. So we have unreactivity reason is non-polarity of the bond and strength of the carbon-carbon bond and carbon-hydrogen bond. That's it. Thank you very much. Have a good day.